Good morning, everyone. It's a pleasure to be here once again, kindly invited by the Digital Twin Hub. Last time we talked about sustainability, and today we are going to present you our little simulation model for managing the S&OP cycle inside a manufacturing company. As me and Tommaso, participate in SC Node, which is an initiative in developing an open source platform focused on advanced supply chain topics in manufacturing and logistics. This project began because advanced technologies are often misunderstood in terms both of implementation and value. And with this in mind, we set two key objectives. The first one is to build a community of professionals and enthusiasts around topics such as simulation, digital twins, and data analytics. And secondly, we want to enable this network of professionals to share knowledge and raise awareness of these critical technologies, making them more accessible to a broader audience. Today, we would focus on how digital twins can support the decision-making process inside a company with the process of sales and operation planning by presenting you a case study. So first of all, let me introduce what is sales operation planning. It is basically a fundamental process for aligning a company's strategic direction with its operation and sales planning. So while the process can vary significantly across industries, there are certain core characteristics that remain consistent. First of all, for what concerns the organizational structure, sales operation planning brings together executives from different departments, primarily operation, logistics, sales, and finance, to align their objectives through a common strategy. And secondly, moving to managerial implications, sales and operation planning is about managing complex trade-offs between different goals, KPIs, and development plans. At last, also information system requirements could represent a burden for the companies since S&OP involve processing large volumes of data, which must be correctly aggregated to generate meaningful insights for decision makers. So given this multitude of constraints, the need for a robust decision support system becomes evident. In this case, among the available approaches, we find out that digital twins enabled by simulation modeling emerge as the most effective solution for addressing the complexity and uncertainty of the strategic planning. Compared to other methods, digital twins excel first of all in accounting for the stochastic nature of key supply chain variables, such as demand fluctuations and production parameters. Moreover, digital twin enable the so-called what-if analysis through scenario development and large-scale testing. And at last, by embedding supply chain complexity within the model, decision makers can focus on managing the right levels to achieve their objectives. In conclusion, building a detailed digital twin to quantitatively support the sales and operation planning can significantly enhance both the quality and the efficiency of decision making, not only in the short term, but more importantly for the long-term strategic success. To illustrate this concept in practice, I will now hand over to Tommaso, who will present a case study on the application of digital twin to S&OP.
Thank you, Pietro, and good morning, everyone. Today, I'm excited to talk about the transformative impact of a digital twin on sales and operation planning. And as an example, we'll focus on a steel bar manufacturing company for which we created a POC in 2022, which has been lately incorporated into the corporate IT systems with a brand new interface. So how does a digital twin applied to S&OP actually work? Well, in the context of S&OP, the digital twin integrates data from various sources, including sales forecast, production data, inventory level, and other supply chain factors. So also, what does the digital twin consider as input? So it considers finished product demand. So typically, demand sensing and sales forecasting are the first steps to compute the product demand. but in this case, this password was delegated to the steel manufacturer forecasting suite, from which we received the product demand as input in the digital twin. It considers inventory data, so current stock level of raw materials like steel and other metals, work in progress and finished good, which are crucial to net the demand of what has already been produced in order to define what's so-called production requirements. It considers operational constraints like machine downtimes, labor availability, and capacity limitations, which are added automatically from the system and are reviewed by the responsibles to estimate the available production capacity. Last, production data. So as the last step of the S&OP cycle, information on cycle times, machine performance, and output rates allow to challenge the demand production feasibility. So one of the most powerful capabilities of the digital twin we design is its ability to enable dynamic production and stock policies. So basically, it allows the manufacturer to define its production and inventory management strategies in response to real-time data and day-to-day situations. This is done in order to smooth production peaks and avoid overstock and stockouts. Regarding the dynamic stock policies, the digital twin allows to test the impact of different service levels on a flexible set of products to compute the stock levels for raw material, work in progress, and semi-finished good based on up-to-date data to achieve the intended corporate risk profile. By considering both historical inventory and future demand, it predicts how inventory levels need to be adjusted to avoid excess of stock or shortages. Impacts on cash flow and storage costs is also calculated in this equation. Regarding dynamic production policies, the digital twin can simulate different production scenarios and policies like make to order, assembly to order, and make to stock, taking into account the stock policies, available inventory, and machine capacities. The production plan is then computed, so basically what to do, what to produce, and challenged by the available capacity in a waterfall scheme. Last but not least, the system considers the quantities produced to net the demand and the production requirements. In any moment, if a delta between planned and actual values are detected, it is possible to use the digital twin again to define how to realign to the goal set. In summary, the digital twin plays a critical role for the S&OP by boosting the supply chain flexibility through dynamic production and stock policies. It empowers manufacturers to overcome business unit silos by constituting a common platform where data-driven decisions can be tested and challenged. This is done to improve, of course, responsiveness to market fluctuations, reduce inefficiencies, and in the production process. And this not only helps optimize cost, but also ensures that the customer demand is met in a timely manner. Thank you.
Our next question here for the S&O team is, how are you ensuring your platform is interoperable with the large landscape of business systems used in manufacturing?
Mm-hmm. Yeah, so basically, the idea behind the digital twin is that is let's say applied to the S&OP, which is pretty, let's say, quite standard, let's say, process in all the business. Of course, they have peculiarities and so on, but then it comes to a sales forecast, for example, to have production data out of the field, and basically leans on what we can call standardized data. Of course, there might be differences in some of the data sets that are being used, but nonetheless, it typically supports what is the data that is typically used in an S&OP cycle.
Very good. Thank you very much. A linked question for yourselves, SC-Node, is what is your definition of digital twins?
Yes, I take that. The definition of the digital twin is quite broad. So in our vision, digital twin should be, first of all, a support decision-making tool. So it should enable capability in decision maker to support their ideas with quantitative data. So by integrating several different data sets, both with real-time or non-real-time information, digital twin should be an aggregator of numbers and should be capable of delivering high accuracy results for supporting the decision-making process. Especially in sales operation planning, decisions are taken at a higher strategic level, so they cannot rely just on numbers. And for this reason, we should define the digital twin to support S&OP as an additional tool in all the possible managerial tools and skills that are required to perform and take the kind of decision required at strategic level.
And it's a question probably applicable to both presentations, but whoever would like to go first, maybe the team from SC Node. How do you explain the use of synthetic data in digital twins?
So we should, first of all, give a definition for synthetic data because in this way it's too general, I think. But what we can say is that the digital twin should use both aggregated data, we can call them synthetic if we want, and data coming from quite near real-time processing and collecting from, for example, operational field, machines, inventory, and so on. So by mixing them, you get to the final capability of planning your activities. In the example we provided, synthetic data may be production policy parameters, cycle times, inventory parameters, and all those kind of levers that operation manager and supply chain manager are capable of managing in order to get to the final results of having a detailed planning capable of being both efficient from a cost point of view and also efficacy for what concerns the delivery to the final customer.